So the phase performance requirements, I'm going to quickly look on the next slides at EICIC, MBMS, and COMP. And then talk about the ITU, the telecom profiles for phase and time delivery. If you've been looking at, keeping an eye on deployments of PTP within telecom networks, you've probably heard of the telecom profile. So the first one was to do with frequency delivery. There are two more that are currently being worked on by the ITU that are talking about delivering phase and time over networks. Some of the terms that I'll talk about you'll probably hear are this on-path support. So these two profiles are split in one that talks about full on-path support, another one that talks about partial on-path support. So the requirements for phase, it really goes back to sort of simple E1 type frame structures where you have time slots. You have some transmission medium where you slice up access to it in terms of very defined periods of time. In the case of an E1, 32 time slots, or one frame was an 8 kilohertz frame, so 125 microseconds. If you divide that by 32, you get how much each frame is. So we need then to schedule access, and it's a similar concept in radio, some of the mobile standards, the LTE and TDD standards, where you have a shared transmission medium, whether it's radio, in this case it's an E1 structure, but you have to align things in time slots. This slide is really just the sort of very high-level overview of that. I'll skip over this one quickly. This is really just showing how we build frame structures from those lower order time slot systems. So the EICIC slide, I think Steve did a good job of going through all the jargon busters. We know what it stands for. And it's really a way of scheduling transmission from a macro cell so that a small cell that's underneath it, that's within the same radio area, they can both access that radio resource at the same time. So it requires good phase alignment, tight phase alignment for that reason. They need to transmit or know when to not transmit, so they're not both transmitting at the same time. So the macro cell avoids scheduling in, or it reduces power in these protected subframes. So we come up with this other acronym of these almost blank subframes. And the requirement here, these slides, these figures are taken from Ericsson, taken from an Ericsson presentation. So these have come from Ericsson. They're talking about plus or minus 5 microseconds alignment between these two entities, between the macro cell and the small cell. So you can see, so to deploy these technologies, there is a very, very hard phase alignment requirement. EMBMS, the multicast, sorry, I always struggle with this one. There's too many broadcast multicasts in it. The Evolved Multimedia Broadcast Multicast Service. So it's broadcasting using a multicast service. And this uses a single frequency network concept similar to the way digital video broadcasting is done. So DVB-T, the terrestrial digital video broadcasting, is done using a single frequency network with a microsecond phase alignment for some of the frames. But depending where you look, I'm not sure whether this is manufacturer dependent or whether the standard specifies this. I've not got to the bottom of it. Depending where you get the figures from, there's a disagreement between 1 and up to 32 microseconds. Whether it's the type of implementation or not, I don't know. I've not got to the bottom of that. But it's basically, as we said earlier, a broadcast event. You know, you can imagine users at a large sporting event all wanting to view the same content. So we use multicast services as part of the LTE system to distribute the same content to multiple handsets. And COMP, again from Steve's Jargon Buster, Coordinated Multipoint Transmission. 2 different categories thereof. Joint processing, which is otherwise known as the network MIMO or MIMO, which is multiple input, multiple output. So transmitting from 2 different places to the same receiver, or receiving the same signal a single signal, receiving it in two different places and jointly processing it. So COMP has two flavors, joint processing or coordinated scheduling. It's the joint processing one that I'm going to look at on this slide here. Again, this is from Ericsson, this diagram, and it talks about CPRI, which is Common Private Radio Interface, Public Radio Interface, one of those. Should have had that in the jargon buster, or did I miss it? So again, talking about these radio units receive the same data from two different places and then jointly process it. So it implies that there is this sort of high bandwidth link between the two receivers, so they can do the processing. And this has sort of evolved. I think all these techniques, these LTE-A techniques, are really ways of enhancing spectral efficiency. I think that's the goal of them all, is to use the channels that you've got in a more efficient way. The time alignment here, the significant bit, is the plus or minus 1.5 microsecond required between the cells, and latency less than half a microsecond. But again, this sounds like quite a significant amount of bandwidth here, 1 gigabit per second per antenna. I guess that's to get the resolution on the processing of the RF data.